Right. Let me know when the screen shows because I can no longer see because I'm in presentation mode.
Yeah, very well. It's I don't see it yet, so I think you have to share the screen again.
Okay.
But it's fine.
Okay.
Yeah, it's fine.
All right. Let's try this.
Yeah,
good?
now it's there. So here we go.
All right. I've already been introduced, but my name's Ryan, and I work on SolidJS, declarative JavaScript UI library. Yes, this is another JavaScript framework. So you might be asking yourself, how did we end up with a talk about a different framework in the opening of React Finland? Well, the reason for that is that Solid is a very React-like framework, right? At least on the surface, right? We are all about unidirectional flow, read-write segregation, immutable interfaces, and it's built on a lot of the same building blocks. We have simple primitives, they're hook-like function components, and JSX, and really a lot of the same features. Portals, fragments, context, suspense, async, streaming, SSR, concurrent rendering, the huge list of things, right? But there is a but, and it's a rather large one. Solid is sort of nothing like React. It's built entirely on fine-grained reactivity. This is similar to MobX or Vue, and its components only render once. I'll explain what that means a bit further along. And there's no virtual DOM. Basically, the whole mental model is completely different. Solid shares a lot of the same values, but it's an entirely different implementation. The way I kind of like to think about this is a bit like Black Mirror or one of my favorite 90s shows growing up, which is Sliders. They spent each episode traveling to the current date in an alternative realities where some critical event in the past had changed the present slightly. And that's sort of how I view Solid, right? How different would React be if a different decision was made at the beginning? I've been looking at this pretty much as long as React has existed, although I didn't really start working on Solid until about 2016. But we don't need to go back that far. I actually just want to go back to the first time you saw React hooks. Just kind of get that back, reset your mind back to that point, right? Maybe it was October 2018, maybe it was a bit later, but we're gonna start there. So let's create a counter. The kind you see on every landing page, every intro example. Naively, when you first saw hooks, you might have done something like this. This has more than a few problems. Mostly, though, it's that we set an interval here that updates the count. And as you can imagine, every time it updates the count, it re-renders our counter if this was React. And we create a new interval, and these start stacking. And who knows what you're going to end up with, honestly. And your browser might eventually run out of memory. So what do? Well, we use effect, right? That's what it's there for, right? Now we have cleanup. We can clean up on each execution, and at first glance, our counter would work properly, right? But there's a problem. If other state changes in the component, it actually resets the interval on every re-render. So it won't be uniform. If some new props come in, or some other states in your component, you'll get kind of jagged, inconsistent delays depending on when the other state updates. There is a solution for this, and most people know you just set the interval once, right? We have a dependency array here for a reason, but this has another interesting result. Our counter will start at 0, and then it will move to 1 and never update again. And the reason for this is we have a stale closure wrapping over the count at 0. So every time the interval is called, it just sees count as 0, adds 1 to it, and resets count. We can use the function form of React to actually set the count, but this doesn't account for things like fresh props. And honestly, I didn't invent this example and this progression here. Some people found it in the wild, but Dan Abramoff actually wrote an amazing article called Making Central Declarative with React Hooks. And he kind of goes through the next couple hiccups rather, that happen throughout this process of extracting this into a reusable hook. But I'm just going to, for the sake of time, skip to the end. There's a bit more code here to get on the screen, so hopefully you can still see this. But the gist of it is, through using a ref, we can store the current callback, and that encloses the latest value of state. And then we have our solution. Essentially, every time set interval is called, it can use the new callback, and that will then see the latest state, and when we add one, it'll update. But I want to say, look at where we started from and where we ended up. This comes from the natural impedance mismatch of imperative use interval versus something declarative and pure like a react render function. And the thing is, once we encapsulate this off, into its own hook, it's really nice to use. But why spend valuable minutes of a presentation showing you React hooks fundamentals when I could be showing off Solid? Well, what do you think this example looks like in Solid? Yeah, we're back where we started. I mean, there are differences. I never claim Solid is the same as React. Instead of state, we have signals. The value returned is a function getter that retrieves the internal value and makes through reactive descriptions rather than just the value itself. And we use things like create signal or create effect instead of use to signify that it's only created once, because a component only executes once in Solid. But this example in front of you works perfectly fine. That is all it takes to make this counter. And okay, I'm a bit irresponsible here, so let's add some cleanup, because if this component ever unmounted, we would like to remove the interval. But here's the thing. A lot of compile frameworks, like Svelte or Marco, pride themselves on allowing developers to write less code. But I'd argue it's more than the syntax, that makes these libraries have less code. Sure, you type a few less characters, but it's actually the reactive execution model that enables this. No need for use ref, no need for use callback. But I mean, this is pretty different than React. You're probably wondering a bit how this works. So let's see if I can show you what's going on here. So I'm going to open up our playground here for Solid, and this is our same counter example that I just showed you guys. Now, I've got the console open here so you can see quite quickly what I'm doing, but I'm just going to console log something. What you see here is hi gets written to the console once, and our counter is still updating. And this is because in Solid, it's not the components that re-render over and over again. It's actually the hooks, so to speak, right? If we wanted to write this out lots of times, we would, create effect, which is our analog for use effect. And even then, while this will print out this log, it's still only doing it once. And the reason that is nothing has changed, right? This does not depend on any value that's changed. So let's make it listen to count. Now you can see that in our console, it's actually counting up along with us. The way it does this is very similar to how MobX or Vue works, in that we are dynamically tracking the access of these signals at runtime, which is why we use functions here. So I'm gonna show you a bit more how this works. Okay. This is getting a bit more into the technical details here, but you can view this as a global stack where we keep track of all running effects. Every time an effect runs, it pushes itself onto the stack so that it can be subscribed to by any signal accessed under that execution. That way, whenever a signal's value updates, we can just have it call that effect again. And when it's done, it then pops itself off the stack. Beyond that, we just need the scheduled effect to run the first time so dependent signals can add it to their subscriptions to kick off this whole process, right? As I've mentioned, this is very similar to MobX or Vue. So if you've used those, this should be familiar. In any case, we don't need dependency arrays with this approach. And this mechanism is completely independent of any component. In fact, in Solid, components are little more than the functions you write. And they don't actually own the state themselves. All right. So I pose a question. What if we used effects to update the DOM? All we need to do is get our JSX to compile just a tiny bit differently. Well, maybe not that tiny. What if our JSX produced real DOM nodes? Right? Here I'm just using document create element to create this H2. But if we do that, then updating count only needs to rerun this one function. No component execution, no diffing, no reconciling. Just set the new text content on the text node. Or sorry, in this case, the children of the H2. Is it any surprise why Solid's so performant? Solid gets a lot of attention for being a benchmark winner, but I hope to show the simplicity here along with the fact that this brings near vanilla JS level performance. What we have here is basically just a state library. For some old timers here, this probably sounds a lot like JavaScript frameworks that predated React, things like Knockout.js. I love Knockout.js, but I also love React. It took me years to break out of my old patterns to appreciate React for what it was. It's a philosophy more important than the implementation. Not that React is going to adopt what we're doing here with Solid, but I want to show you that things are a little bit different this time. And that's for 3 reasons. And the best part about it, you don't have to trust me on this. I didn't even invent any of this stuff, seriously. MobX has shown the guarantees we need to make a reactive system ensure that it stays glitch-free, to ensure our updates propagate in an effective and predictable manner. If you've used MobX, you've seen this, but it makes sure that every single computation only gets run once, runs in order, nothing gets out of date, and keeps everything consistent. We have the same thing here. A little lesser known reactive library, SJS, showed that by registering our effects within parent effects, a nested reactive system could automatically clean up after itself. This solves a significant problem we have here with the observer pattern, where it actually frees up stale observers automatically. See, I asked a minute ago, what if we used effects to update the DOM? But a better question is, what if we view all rendering and hook creation as a side effect? Let's explore this for a minute. I'm going to come back to scheduled updates in a few minutes. So this image has been known to give some React developers headaches. Hook rules have kind of preconditioned our minds to reject this sort of nesting. But I just wanted to kind of put it out there that if you kind of onion or nested effects, we can basically create a hierarchy independent of any components. It isn't unlike a component tree. It just isn't defined by how the developer breaks up their code, but how the application itself is actually structured. The key to this is that it's only the nearest effect where the value is read that reruns when the value changes. We use this by using the function, the getters, the proxies to lazily evaluate everything. As I showed in the previous slides, when we update, say, signal D here, it's only these effects that rerun. But if we update A, we actually end up running everything inside the second internal create effect here. This might be a little bit hard to visualize, and I understand that, but you could almost see that this structure of code could be generated from like this application code. Notice in our app component here, A signal kind of determines whether or not we render the child. And that's very similar to here. That's the only time it needs to reevaluate is if, we change whether we are going to display the child or not. And then from there, the rest of the effects here are either, user-written effects or, expressions that you find in the JSX. The takeaway here is there's not much in the way of a rendering system. The whole thing is built with the same reactive hooks that any developer that uses Solid would use. And that brings us back to scheduling, which is something we borrowed from React. React has this sort of 4 stages of render thing going on. First, you have that event, where the state updates. And then you have basically the pure computations that update the render functions, right? We've all seen this equation before. And then after that, React takes the VDOM output, diffs and patches it. And then, when it's all updated and the DOM is updated, it runs your user effects. On the Solid side, it actually isn't that different, except it's hooks that govern this lifecycle, right? We still have our event. And then our pure computations are in the form of create memo, which is our analog to use memo, more or less. And then create render effect. End users don't usually write this. This is what the JSX generates. And then finally, our end user effects. And that's the thing to kind of realize here, right? We are more or less have the same kind of execution pattern of event, pure computation, and then side effect. So we have the same ability to hold off applying our side effects. This allows Solid to do things like concurrent rendering or transitions. So what are we dealing with here? Like, what are we dealing with Solid? Is it an implementation? Not exactly. I don't expect React would ever really follow this path. There's enough differences in the execution model, right? Solid is not a React clone. It's, there's no React compatibility. It's not like Inferno or Preact. The execution model, it really is that different. Language, not really. We're not really trying to make a completely different dialect of JavaScript. Isn't Svelte or Margo, whatnot. It's just your JavaScript that runs. We only transform the JSX. What you run is what you get. So to me, it's a paradigm, right? And it's just simply reactivity. That's all you get here, right? And we can apply that paradigm to whatever we want. For example, if you don't use a DOM element, we don't need to pull in any DOM code. And this means, we can look at stuff like native, as easily as doing suspense on the server for SSR, or maybe spinning some 3D cubes, or, and this is just a communication mechanism. So, and synchronization means, so use however way you want to organize your data, right? How about state charts, right? We just had a nice talk on that. And really, as I mentioned on the previous slide, why not use transitions or concurrent rendering? This is all tools at your disposal. It's just how you model it. And that's what Reactivity does. It lets you model stuff, right? You basically have a low-level abstraction over the simplest of primitives. So, as I said at the beginning, I like to think of this as one of those alternate realities. What if the early developers on React had, instead of looking at, improving upon Angular's dirty checking, looked at something like Knockout.js, right? They might have arrived at something kind of similar to what we have with Solid. So, we're still a small ecosystem, even if I've been chipping away at this for many years. But I hope, those of you who are interested to kind of explore, take on the adventure, could, step through the portal and see what's available to them, so to speak. Thank you very much.
Yeah, thanks a lot. I think it was a great talk, and we move to the discussion. So let's see if people have any questions or comments on YouTube or Twitch. So I just have to, and now signals. I guess that's a good summarization, because I think as far as I understand, signals, they simplify a lot, or they get some complexity out that you want out. When it comes to signals and what you develop, do you still have to worry about keys and memorization and all this, or is it all in the paradigm itself?
Exactly. When you saw me layer this stuff, and I realized I got a little technical, it's always hard for me to really explain the differences without some of the kind of technical stuff there once we get past that set timeout example. But the actual tree is almost naturally memoizing itself. Like, essentially, the layers, the onioning, is just a form of memoization. So for things like for loops, we have special helpers, and they just execute only the parts that need to execute. We basically apply this fine-grained approach to everything. And
so let's say you have a React application and you decide, I'm going to try Solid. So what does it look like when you start porting away from React to Solid? Do you use them like side by side, or what's the porting process?
Yeah, I mean, on the surface for your simple components, it'll pretty much just slide right across, right? But obviously, places where you're using use callback or use ref, there's no real need for those. So there's no, you have to kind of rethink stuff. And I think that is the trickiest part for React developers in terms of learning Solid, is that the mental model is different. It is closer to something like Svelte to a degree, but it's actually all runtime. So it just takes a little bit of knowing, this is a signal, not just a value, right? It's not just top down running. It's event based, more or less.
Mm-hmm. Yeah, that's really cool. We have a question. What will be the trickiest parts of SolidJS for a standard React developer? How is the learning curve?
Yeah, the concepts are the same. The API is very similar. That's positive and a negative. The positive, as I said, is when you start doing the simple stuff, it just kind of works. The negative is you might not read the docs or do the tutorial or whatnot, and kind of find yourself with slightly the wrong mental model. Basically, the biggest, and this is as far as I know, the gotcha here is since we're lazy evaluating everything, where you access your data matters. Most of the time, this has no effect because you generally access your data where you use it. But like MobX or Vue's setup function, you have this scenario where, if you prematurely destructure props coming in, then you can lose reactivity. And I think that's really the one thing that time after time catches developers. Once you're going to go, don't destructure props coming into your components, the rest of it kind of just flows together.
Then there's a question about performance. How does performance compare to something like React?
I try not to talk about this too much, but Solid's performance is pretty impressive. In terms of benchmarks, in terms of any kind of thing you look at, I don't want to kind of drill too much into it because there's some truth to the fact that performance doesn't matter that much, but you'll see that in most benchmarks, Solid is way out in front of most frameworks, and it is very it's closer to vanilla JS than it is closer, say, to React.
So how about the size of SolidJS?
It's generally speaking pretty aggressive tree shaking. For small apps, something as Svelte is still smaller. They put more code into the components and less into the runtime. But I found that the tipping point of that is about 3 to-do MVCs, essentially in size. So once your app gets about as big as Hacker News, Solid starts being smaller than Svelte in terms of size.
Yeah, that's a very interesting point because there's always some cost to this compilation and all that. So let's say you're a React beginner. How do you use SolidJS? So
Yeah, I was going to say, just go to the website, play around the tutorial. There is also like a solid state library for React if you want to play with it, but I don't feel that gives you the full impression. I think really we have our REPL, we have a tutorial very similar to Svelte, inspired by Svelte's tutorial. And I think that's really the easiest way to kind of get started and just kind of play with it. The solidjs.com website has that all linked up and in there, and you can just try different stuff.
Right. So head up to the website and then start doing stuff. Makes sense. How does the term concurrent rendering make sense here when you directly update the DOM? Do you somehow store effects to apply?
Yeah, actually, the truth of the matter, this is all queuing and scheduling behind it. One of the biggest innovations, I guess, with Solid on this side is that the reactive, like React has fiber internally, so you have all these fine-grained little updates. Solid's hooks are already fine-grained, so we can just go, oh, this is an effect, and you're in a transition. Just stack those off and queue them when the pure computation part is done. Right? We do the fetching, like say the resource fetching, as part of a pure computation, and then we wait for it all to settle, and then we apply it. And it's a little bit more complicated than this, obviously, but essentially we fork reality on the pure computations, and then as new updates happen, if they're under the transition timeline, they just apply to that transition. But if they're outside, we can actually apply it to both realities. And in so, we can actually have multiple realities rendering at the same time. And then when the time comes and everything settles, we basically replace the current reality with the transition reality and apply all the effects.
Yeah, let's say it's impressive. Because I think one of the hard parts in React is always like animations and transitions and dealing with this stuff. So it's great to hear that there's let's say there's an alternative solution. Are there any plans to create something equivalent to Next.js or SvelteKit supported by the core team?
Yeah, definitely. Already in works. It's called Solid Start. I'm going to say it's an alpha, like it's an alpha. I've broken it, I think, 3 times this past week. So like seriously, don't really use it. But if you want to try it, you can. It's basically very inspired by SvelteKit. Again, take a lot of inspiration from that. It's based on adapters, uses Vite, has file system based routing, supports streaming SSR out of the box. Basically, and works on different platforms like Cloudflare and whatnot. That's basically the plan here. It's going to take us months, realistically, to get it to where it needs to be. But yeah, we're already working on it.
Yeah, that's cool. And I have a nice comment. So Jorge, hopefully I pronounced the name right, thinks that SolidJS is accomplishing what any new React libraries want to achieve, which is to render less. And then SolidJS goes one step above this because it's rendering only one time. Or like, let's put it this way: that it's impressive what Solid is doing rendering wise. So
Thank you. Took a while to get here. Recently, there's been other people seeing what we've been doing here. And the truth of the matter is, Giselle is just a state library. We've seen some great work being done by even like Daishi, who works on Jotai and stuff, and just playing around with a lot of similar concepts of just taking a state library to render without React. There's a lot of gotchas and caveats I've learned over the years. So I published the core of Solid actually as a framework, as a reactive library independent module called DOM expressions. But I'm super stoked that this has kind of spawned people into kind of thinking about how to approach state and rendering like in a completely different way.
right, cool. And does Solid have UI components or widget libraries?
Yeah, basically 1.0 went out, I guess, 2 months ago now, and this has kind of been the calling point to kind of consolidate on the ecosystem. Before, there's people kind of playing around with stuff, but we didn't really have much of an ecosystem. So I wouldn't say that today I have the components to just push on to you. There's works on core to carbon components, headless UI. Come to our Discord channel. You can see the activity going on. There's a lot of work in progress going on right here. Even though I've been working on this for a long time, I really feel like this is the launching point in terms of building up the ecosystem.
So related to this question, do you have experience with something like Tailwind? Because they have a lot of UI. They have a lot of sort of starting points for components. So do you have people working with Tailwind that just take their ideas or UIs and port them to Solid? Or
yeah, definitely. I mean, there's certain things that we get for free with our tooling using JSX and whatnot. And I know that people have been working with Tailwind CSS in some of our starters. There's Windy CSS. There's so many different compiled options. One of my favorite things, though it's not Tailwind per se, is Vanilla Extract, which is this compiled TypeScript styling solution, which has basically zero runtime. And because we use the same tool chains, there's a lot of opportunity to actually use this stuff with Solid, even if we don't have React execution compatibility. Just like dealing with JSX or having like simple ways to insert it, it's that part is almost the same patterns. So yeah, I've seen some really cool demos with Tailwind, for example. But there's still a lot of noise from the early community just throwing library ideas out there and people trying them, right? It takes a little bit for these different things to gain traction.
Yeah, speaking of Vanilla Extract, we have a demonstration by Mark on Wednesday. So if somebody wants to learn what it's about, it's a good chance to do it. And then I guess this one, somebody is waiting for Material Solid.
Yeah.
So I guess that will be one way to solve it. Because if somebody writes a wrapper, then
as I said, come to the Discord if you want to work on this. Come on over. As I said, there's a few of these going on, but yeah, I imagine in the next several months we'll see a larger growth. A lot of interest has kind of been renewed or shown up for the first time now that 1.0 is out.